Okay, this video is going to be about confidence intervals when the standard deviation of the population is known. And since we know the standard deviation of the population, we can work with a normal. So first off, confidence interval, what is it anyway? It basically just says how far we believe the population mean might be from our actual sample, where the actual population mean is in a range. So it's basically giving us the two values. So if I were to create a 95% confidence interval and just using the empirical rule, I would go, well, you know what, empirical rule, it's centered at 0. We have 1, 2, and 3 standard deviations to the right and -1, -2, -3 to the left. And if I wanted a 95% confidence interval, that means I'm 95% certain that the population mean is going to be no more than 2 standard deviations below our mean, our sample mean, and no more than 2 standard deviations above our sample mean. And our formula is going to look something like this, and this is something we're ultimately going to need to memorize. And Z star is tied directly to our confidence level. So it's tied directly to our confidence level. In this case, we wanted 95%. So in that case, it'd be our Z star would be 2, our X bar would be 0. And we didn't have these two values, so we can't worry about that here. But this would essentially be saying 0 plus or minus 2 standard deviations for the 95%, and then sigma divided by the square root of n. Now, in this case, we didn't have an actual population standard deviation, and we didn't have a sample size. So we're going to go ahead in the next part and kind of lay that out using the same formula. So for our next one, we're going to say, you know what, we have a standard deviation of 12.5. Our mean is no longer at 0, it's at 77. So our X bar, this is our sample mean, and our N is 25, and our sample size is 25. And the reason that's going to be important is we're going to say that, well, 12.5 is our standard deviation. Our sample size is 25. And if you'll remember, the standard deviation of the sample means is the standard deviation of the population divided by the square root of n. So 12.5 divided by the square root of 25 gives us 2.5. So the distance is 2.5 between each one of these. So that's our measurement rule. And I'm going to do this by empirical rule. So this is not going to be calculator accurate. It's just going to be it's going to be approximate. So one standard deviation would be 75 plus 1, 12.5 divided by the square root of 25, and 77 minus 1, 12.5 divided by the square root of 25. And if I did that, I would find out that this particular value would be 74.5. This upper value would be 79.5. So if I had a sample that had this standard deviation and this sample mean, I'd be 68% sure that the true population mean fell between this interval of 74.5 and 79.5. On the other hand, if I wanted to be 95% confident, I'd need to be plus or minus 2 standard deviations, in which case my upper bound would be 82 when I calculated this, and my lower bound would have been 72. And I'd be, you know what, it's no more than 5 away, 5 below, 5 above, or 5 below. I'm 95% confident in this case. This one would be 95% confident that it fell within this interval, just like we said that this was 68%. Then if I went all the way out to 3 standard deviations, 3 standard deviations below happens to be 69.5. And 3 standard deviations above happens to be 84.5. And from 69.5 to 84.5, I'm 99% certain that the true population mean will fall in this interval. Notice X bar is always going to be in the center every single time. So X bar is always the center, and that's what our formula says. Our formula up here says that X bar is going to be the center of every confidence interval. Z star is our confidence level. So this is basically, if we're 68%, this would be a 1. If we're 95%, this would be a 2. If we're 99.7, this would be a 3 standard deviations. And we already said that this was going to be 12.5 divided by the square root of 25. Now, there's another way to go about this, and this is on the calculator. All right, so on the calculator, we're going to get slightly different answers because this is what we had above using the empirical rule. On the calculator, it's going to be a little more precise, and here's the way you go about doing that on the calculator. We're going to go stat, test, and we're going to drop all the way down to number 7, which is Z interval. Press enter, and our standard deviation was 12.5. That was the standard deviation of the population. And we're using a Z because we have the standard deviation of the population. Our sample mean was 77, and our sample size was 25. And let's do a 68. So we put in 0.68 for our confidence level. And then we end up getting 74.5 to 79.4 as being our interval. And notice it's a little bit different, and it's just different by rounding. Then we go back and we do the same thing, stats, test, Z interval. If I want to do a confidence level of 0.95, I just drop in and put in a 0.95. And I find out that it lies between 72.1 and 81.9. And then finally, if I wanted to do for 0.997, we get 69.58 to 84.41. And that would be at 99.7. All right. So that is working with a confidence level when the standard deviation of the population is known. Okay, so in this case, we're able to work with a normal. All right, hopefully that'll help. The next one we will do when the standard deviation of the population is not known, and we'll have to work with a T. Thank you.